In this video we'll look at number 11 and 12, which are both some applications of using logs. So let's look at number 11. In 1935, Charles Richter determined that the magnitude of an earthquake could be measured on a scale according to the formula m equals log n. M is the magnitude, n is the intensity. So the strongest recorded earthquake of all time had a magnitude of 9.5. And by comparison, the Whittier earthquake of 1987 had a magnitude of 5.9. According to the Richter scale, how many times more intense was the Chilean earthquake compared to the Whittier? So we're solving here for the intensity, which is n, given the magnitude m. So for the Chilean earthquake, we're given a magnitude of 9.5. and we'd like to know the intensity of that quake. Similarly, for the Whittier quake, we're given that the magnitude was 5.9, and we'd like to know the intensity of that quake so we can compare the intensities. Here, since we're not given the base in the problem, we're assuming it's a base of 10. So in this case, we would be determining that 10 to the power of 9.5 is our n value. And then in this case, this would be 10 to the power of 5.9 is equal to n. So if we're comparing these, you can evaluate this and you can evaluate this, but we know this one is going to give us a larger value. So if we're comparing how many times more intense this quake was compared to this quake, we'd want to do 10 to the 9.5 divided by 10 to the 5.9 and compare what that ratio gives us. So 10 to the power of 9.5 divided by 10 to the power of 5.9, which is 3,981 approximately. So that means even though this was 9.5 magnitude and this was 5.9 magnitude, the Chilean earthquake was actually 3,981 times more intense than the earthquake in Whittier. Let's also look at number 12. So to determine whether a substance is acidic or basic, its pH can be determined by this formula. pH is negative log of H+, where H+ represents the substance's hydrogen ion concentration, measured in moles per liter. So an unidentified juice is being tested to determine whether it's safe for children to drink. To be approved, the juice must have a pH between 3 and 7. If the hydrogen ion concentration is 0.003, will the juice be approved? So this is the H+. And we're going to go ahead and determine the pH. So pH is equal to negative log of the H+, so 0.0003. If we're evaluating this, since this is log base 10, we could use a calculator to do that. So negative log 0.0003 is equal to 3.52. The pH is equal to 3.52. So since we fall between the acceptable pH levels, between 3 and 7, it will be approved.